hydrochloric acid.
Is that the stuff that can burn you?
That is the stuff that can burn you.
Why do you keep giving us danger?
Yeah.
Guys, stop playing with dynamite and fire.
Secretly trying to do it. It's not been successful so far.
Can we just skip today and do it tomorrow?
What are you doing?
Alright, so what we're going to do, up to this point we've talked about moles of solids, moles of liquids. Those are pretty easy to handle because you can mass them. You can take a solid and you can put it on the balance, and you can take a liquid and you can put it on the balance, and you can find the mass. And if you know the mass, what can you find? Other kind of stuff. What else can you find? You can find the moles. Alright, now with a gas it's a little bit more difficult because what can you really not do with a gas so much?
Mass it.
Yeah, you can't mass it. So you can't put it onto a balance. You can, some masses are a little easier to do that than others, but these are not. We're going to be producing hydrogen gas. So your lab today, we're going to be using magnesium, which we have used before. We have. It's that little metal, that's the stuff that we burned. That wood, right? A little metal strip. We're going to add magnesium to hydrochloric acid. Okay, 6 molar hydrochloric acid. This is pretty strong stuff. I actually just got a big whiff of it, and it is burning my mouth. It's like the top of my mouth is. Don't breathe it in. Or spill it on you. The 6 molar hydrochloric acid will be in a fume hood, just like we had it last time. It's in a little squeeze bottle. You're going to add 10 milliliters of it to your test tube, and we'll look at that here in a minute. I'll do a demonstration to show you exactly what you're going to do. But leave it in the fume hood. Don't take it out of there. If you feel like you get it on you, make sure you wash your hands with soap for not, 4 seconds, for a long time. Okay, make sure you get all of that off of you. If we add magnesium to hydrochloric acid, what are we going to get?
Magnesium chloride.
Yeah. How do you write the formula for magnesium chloride?
Oh my goodness.
What is the charge on magnesium?
4.
Okay. Magnesium is here. So what is the charge on magnesium? 2 positive. What is the charge on chlorine? 1. So we have MgCl2.
That's right.
What else is going to be produced?
Hydrogen gas.
Hydrogen gas. How do you write hydrogen gas?
Diatomic.
Yay, we're getting that one. Alright, it is diatomic. So you write it as H2. Okay.
Not quite balanced.
What do we have to do to this? Balance it. How do we balance it?
Well, you have to put 2 on the hydrogen since there's 2 on the other side.
Yeah. This is a pretty easy one. Okay, now if we look at this, if you have 1 mole of magnesium, how many moles of hydrogen are you going to get? 1 mole. Okay, so that would be pretty easy. So if we were to put 1 mole of magnesium into our test tube and add enough hydrochloric acid to react all of it, how many moles of hydrogen would we get?
1.
1 mole. Now the problem with that, what is the mass of 1 mole of magnesium?
Like 50.
24.31.
24.31. That is a lot of magnesium. Okay, that is not really a good thing to do, economically or just time-wise. So we're going to use a lot less magnesium. All right. So we're going to find what about our magnesium before we start? The mass. And what can we convert that into?
Moles.
What if we only use 0.02 moles of magnesium? How many moles of hydrogen should we get?
0.02.
0.02. Okay, so we aren't going to use that much.
So you're going to find the mass in moles? Or not the mass in moles, but...
Okay, so how are we going to figure out how much hydrogen we have?
What is that whole displacement volume thing?
Okay, it's kind of hard to find the mass of that hydrogen, but can we find the volume?
Yeah.
Okay, remember we take our little graduated cylinders, we put it in water. If we start collecting gas to this level, can we figure out how much volume we have?
Mm-hmm.
Okay, the problem with that, what kind of gases do we have in here?
Oxygen.
Well, okay, remember
Hydrogen.
we're starting this full of water. or full of a liquid, so there's nothing.
Oh, so it'd just be hydrogen.
Okay, we're gonna have some hydrogen in there. But what else are we gonna have in there?
Water?
A little bit of water. There's gonna be a tiny bit of water vapor. Okay, that was the partial pressures that we were talking about yesterday. We're going to have to account for the fact that this is not all standard. And we'll talk about that a little bit more when we get our data. We'll talk about those calculations a little bit more and how to find that. So one of the things that we kind of need to keep in mind is that gases have different volumes at different temperatures. When we did this lab, when we collected the gas in November, definitely a different temperature than it is today. Is it going to be warmer or colder than today than it was when we did this last?
Warmer.
Quite a bit warmer. So what's going to happen to the volume of our gas?
It's gonna go up.
It's going to go up a little bit. So our volume is going to be a little bit bigger because our temperature is higher. We're also at a different pressure. So one of the things that you're going to have to record is the temperature of the room, and then we will look up the partial pressure of water because of the temperature. We have to look that up. I'm not sure what it is. Depends on the temperature, depends on the pressure. And then you are also going to record the pressure in the room. I have a LabQuest set up on my desk. There's a temperature probe and a pressure probe. So after you collect your gas and find the volume of it, go write down what the temperature and the pressure are. Okay, write down those pieces of data. Don't forget to do that. I think that's all I need to tell you right now. Okay.
So the only thing we mastered was magnesium.
Mm-hmm. Yep.
And did you look out in moles or grams?
Grams. You will convert it to moles
Oh.
eventually. But for now, for the data part of it, we'll just find the mass.